This is Hacker Public Radio episode 3369 for Thursday, the 1st of July 2021. Today's show is entitled Linux Inlaws S01E33, The Return of the Rust, and is part of the series Linux Inlaws. It is hosted by Monochromic and is about 64 minutes long and carries an explicit flag. The summary is a show with Steve Klabnik on corroded metal, hipster programming languages, and the analog world.
This episode of HPR is brought to you by anhonesthost.com. Get 15% discount on all shared hosting with the offer code HPR15. That's HPR15. Better web hosting that's honest and fair at anhonesthost.com.
This is Linux Inlaws, a podcast on topics around free and open source software, any associated contraband, communism, the revolution in general, and whatever fancies your tickle. Please note that this and other episodes may contain strong language, offensive humor, and other certainly not politically correct language. You have been warned. Our parents insisted on this disclaimer. Happy Mom? Thus, the content is not suitable for consumption in the workplace, especially when played back in an open plan office or similar environments. Any minors under the age of 35 or any pets including fluffy little killer bunnies, your trusty guide dog, unless on speed, and cute T-Rexes or other associated dinosaurs. And this is Season 1, Episode 33, The Return of the Rust. Martin, how are things?
Things are great and wonderful. We have a special guest tonight.
Yes, we do indeed.
Project, so that's great.
Indeed. His name is Stephen Klavnik, but without further ado, Steve, why don't you introduce yourself?
Yeah. Hi, everybody. I'm Steve. Thanks for having me on. I've been doing open source software stuff for a really long time at this point, but my project over the last couple years has been the Rust programming language. And so that is, probably what we're going to talk about most here today. Before that, I worked on Ruby and Ruby on Rails and some other shenanigans. I've been around for a while, even though I was a user first for a long time before I did maintainer stuff. I had a 5-digit /.id. Maybe it was low sixes.
Wow.
I was a kid at the time, but
okay.
Yeah, I remember riding my bicycle to the local library because they had internet to be able to read /. So I've been around for a minute now.
Internet in the library, hang on, let's just give your age away.
The cat video network, normally known as the internet, has a vicious rumor on you in it. It basically says that you started coding at the tender age of 7.
Yeah, I mean, it's always hard to remember exactly. That's the closest date I can specifically remember. But I've been programming long enough that I don't remember what it was like to not know how to program. And if I triangulate the events, so specifically, my uncle was really into computers in the 80s.
Wow!
He did a whole bunch of stuff. He did the whole flip the physical bits and hit a button to save the byte into the machine, kind of he was involved back in those days.
Okay.
And so he brought a Mac Plus home to my grandparents' house to show them this is what I'm doing with my life. Here's this computers thing. And I happened to be around, and I was a small child, and so I think this was about when I was 7.
And you fell for a Mac, okay?
Yeah, basically. Well, so the thing is, he pulled up Colossal Cave Adventure, So that had been ported to
I
Mac
see.
at the time.
Okay.
And so I was like, oh man, I just like wanted to play that game forever. So then like a couple months later for Christmas, there were all these like computers you could buy out of the back of like the Sears catalog. And so I got this computer as like based on a Z80 basically, but it had a BASIC interpreter on it. And so I just like learned how to write stuff in BASIC on this like tiny little computer. And that was sort of the start of that. So yeah, I was like about 7 years old, very young.
So there's a little bit of a journey involved, right from writing BASIC at the tender age of 7 right up to Rust. For the 2 people in the audience that do not know what Rust is, maybe you can explain what this. I mean, you see, every time I go to one of these hipster coffee shops, I see people with the MacBook Pros typing away, doing the next big thing, inventing the next big thing. But you see, over the last 5 years, more and more MacBook Pros have this little sticker that looks like a cork with an R in it on them.
Yeah.
So there must be something going on.
Totally. So so Rust is a programming language first and foremost. So you use it to write software, and you can use it to write a lot of kinds of software. But the sort of I like to think about things in a historical way. So the reason that like Rust sort of came into existence was to do stuff in the systems space. And that word is super overloaded. But I'll get into that in a second. But to make it like better and specifically more safer. And so what that means is like kind of complicated, but Mozilla picked it up to help Firefox be better. So you can imagine like you're implementing a web browser. You are doing so in C or C++ because that's what every browser is implemented in at this point. C++, but of course there's some C and everything basically. And so Mozilla was like, we want to make it better. We think that one of the ways to make it better is to have a better language for doing this work. And so they picked up sponsorship of the Rust project as sort of a long-term effort to make that happen. One of my favorite bugs on Firefox was actually closed a couple years ago. And it was someone who had reported a corruption in a preference option somewhere. And that bug had been filed like 15 years ago. And they recently rewrote that component in Rust. And when they did so, it fixed the bug and they closed it. And I was laughing. I was like thinking about like, okay, imagine that you could tell the future. Like you would go back in time to that bug. This person files this small corruption issue. And you're like, okay, we're going to fix this bug for you. But first, we're going to go off and make a whole new programming language first. And then we're going to come back and rewrite the subsystem. So you'll get this bug fixed, but it's going to be like a decade. So anyway, yeah. So that's like kind of the thing. So Rust has a lot of this sort of like low level kind of programming is sort of in its blood. However, for various reasons, it also can feel a lot higher level. And so there's a lot of people who it turns out have wanted to do lower level programming, but have felt either intimidated or like unwelcome by the low level like ecosystem. And so Rust has kind of like positioned itself in many ways as like many programmers sort of first lower level language that's more familiar and approachable to them. And so we have a lot of folks who are from sort of like Ruby, JavaScript, Python backgrounds who are now writing device drivers because they picked up Rust for whatever reason. And so that's kind of the sort of where Rust fits in the landscape. So it's kind of like a very low level language, but it feels a lot higher level a lot of the time. So there's a lot of CLI tools that are being written in Rust now. And there's like web services even that are being written in Rust. And so it's kind of all over the place. Turns out you can use languages for almost anything.
Cool. Yeah, I mean, I think what you haven't mentioned is how you got involved in the whole. Because I think you mentioned you were doing Ruby before. Is that right?
Yeah, I was doing Ruby and specifically Ruby on Rails. And it was kind of a fun thing whenever you work on something for a really long time. Eventually, like I really liked programming in Ruby and I liked using Ruby on Rails. So I kind of set a personal goal for myself to like, I would like to get one patch into Rails someday. And then I got a patch in and I was like, cool, that was fun. I want to do that again. And so then I got 3 or 4. And then I was like, I want to be on like the team for Rails and maybe even the team for Ruby. And so I started getting more and more patches in. Eventually I was on the Rails team. And then at some point you're like, okay, now I'm working on my framework and my language. Like, where do I go from here? Like, I sort of, I was like burned out is kind of wrong, but I felt I had like accomplished all that I could accomplish. And I was sort of like looking for whatever's next. And I don't live where I'm from. So I went back home for Christmas to visit my family. And I grew up on a farm in the middle of nowhere, sort of, kind of. And so I didn't have a whole lot to do. And so I was reading Hacker News, and there was this Rust 0.5 has been released, like, item appeared. And I was like, oh, I like programming languages. I should check this out. And I read the sort of like basic documentation they had at the time. And I thought, oh, this is kind of cool. I want to give it a try. I got nothing to do. I'm hanging out. So I did. And I tried Hello World, and I couldn't get it to compile. And I was like, oh, man, this is kind of weird. And Rust had a reputation that was well-deserved back then for changing pretty much all of the time. And so they said, hey, drop by our IRC room and ask for help. And so I was like, okay, I know that, like, jumping into an IRC room to ask for help for compiling Hello World, like, I am probably going to, like, you're laughing because you know exactly what I'm going to say, right? Like, I'm probably going to be told to, like, bad things are going to happen to me.
Yes.
But I was bored, and, like, I don't know, I've been on the internet a long time. I can handle some trolling. So I was like, fine, I'll just do this because I'm curious. So I did. And instead, what I got was, oh, a new person. Welcome. Yeah, sorry. It turns out at the last minute, we actually, like, made a small change here. So you need to, like, add this change instead to get it compiling. We're really sorry about that. If there's anything we can do to help you learn more Rust, that would be great. Feel free to hang out and ask questions.
Wow.
And I was like, holy crap, these people are awesome. And so I was like, I'm going to just, like, hang out. And it turns out that wasn't a one-off event. It just turns out that the Rust folks were really nice and really helpful. And so I just, like, hung out in the IRC room and started, like, learning stuff. And so it kind of just grew from there.
And that was 2011 or something?
2012, Christmas 2012.
Okay.
So yeah, it's been a long time.
So from your, I mean, when you described your Ruby story and onwards from that, you're not so much interested in the application of the language or the technology anymore. You're more of the building of the foundations.
Yeah, well, at that time I was. So my current job actually is writing, like, basically embedded firmware in Rust. So I am very much, like, I still do work on the language, but, like, not as a job anymore, purely as a hobby. And so my job is actually writing stuff in Rust. So now I'm more into the application of things. And I do think also, I think you can't remove these two. So it's like, you need to be in touch with your users to make a language work well. So there's always a balance there, right? So you want people that are working on the language full time, but you want to make sure they're connected to the people who are using it. And that's actually one of the reasons why I continued to stay involved was, so, like, not only was Mozilla picking up sponsoring the language, but they were also working on this Servo project, which was, like, rewriting a new browser in Rust. So you sort of already had one big application that was not the compiler being written in the language. And that did a really good job of providing early feedback on what worked and what didn't work. And this is also why I personally spent a lot of time hanging out in chat rooms and on message boards, talking with people who are using the language and finding out what their pain points are. And we sort of made that a really big culture in Rust in general. Like, we run a yearly survey where we ask users to tell us what we're doing well and what we're not doing well. And we try really hard to get that feedback loop and make it as short as possible. So I was interested in the early days, especially about just the building kind of aspect, because I'm sort of like a programming language nerd. Like, I like that stuff in of itself. Mm-hmm. But if you want to make a product that's useful, you do need to make sure that you're talking to people just using the language and not just, like, make the language whatever you want.
Definitely.
This is not ADA, right? Or ADA, as the Americans call it.
Yeah, totally. I mean, I think that they did do a thing that was good for their initial users. It's problem just that their initial users is very niche, which is like the Department of Defense. Like, there's only one Department of Defense. And, even if you're dominant in that niche, which they no longer are, from what I understand, you can get caught up in.
No, even the Dutch Navy used ADA as well.
Well, the way it was portrayed to us, basically, we had this at university. It was a language designed by committees and improved by committees, and that was the point in time when I tried to run away, but I couldn't, because I had to take that quiz because I had for my credits about 35 years ago or something. Now, a quick question: Mozilla started Rust in 2006 or 2010?
Yeah. So what's kind of interesting is that so it was a personal project of a Mozilla employee. So kind of like what happened was, at one point, Mozilla said, we want to spin up like a research department. So this became Mozilla Research. And so Brendan Eich, who was the CTO at the time, basically said, like, I want to start this whole division to do research. if anyone has personal projects they think are suitable for Mozilla's mission, then you should tell me about them, and we'll consider turning them into Mozilla projects. And so Graydon Hoare, no relation to Tony Hoare, even though they share, both are awesome computer scientists and both share a last name. Graydon was an employee at Mozilla at the time, and he had been working on Rust as a personal project. And so he kind of pitched it as Mozilla should be interested in this because it would help us make Firefox better. And so I think, if I remember the dates right, Graydon started it in 2006, but Mozilla adopted it in 2010 because he had been doing it on its own and kind of it already existed as a personal project. So yeah, so it's kind of both. And then it hit 1.0 in 2015. So we kind of have, it's hard to determine when things start. But like, yeah.
And it has been self-hosting, as in when did you start the bootstrap process? Pretty early in the process, right?
Yeah, I think it was in like 2011. It was already bootstrapped when I started using it in 2012. So I think it was somewhere around then. But yeah, it was written in OCaml originally, and then eventually self-hosted afterwards.
But for some strange, odd reason, Rust is not known as the language to write compilers in.
Yeah, I mean, it's interesting because it inherits a lot of the stuff that's good from OCaml that like makes compilers nice. And there are a couple. Facebook actually is porting over one of their compilers to Rust right now. I'm
really?
Not sure if it's
okay.
Yeah, it's for the Hack compiler, their Hack language. I think it's like an ML that compiles to JavaScript, or is it Reason? Facebook has like 12 languages, and I always forget which one is which, to be honest with you. But one of them, they're rewriting it in Rust right now. So we'll see. But yeah, you're right that it's not like there is like a ton of really famous compilers in Rust currently.
No, it's interesting because just in a side note, you probably know a package called PyOxidizer that is used to package Py packages, as it happens. And this is mostly written in Rust and not in Python.
Yeah, totally. And it's kind of interesting because part of the reason that project came into existence is because Mercurial is written in Python, but they're slowly writing more and more of Mercurial in Rust. And so PyOxidizer is kind of created as a way to make Mercurial work better, yada, yada. So yeah.
Mercurial is still alive.
Yes, it is. Actually, it turns out...
I thought it was dead, okay?
Yeah, so, here's a really interesting thing. Since this is a free form, we can get into tangents podcast.
By all means.
Yeah, so I, like many people, preferred Git over Mercurial, and so I kind of ignored Mercurial too. But what's interesting is Mercurial kind of found a niche in, like, monorepos. Like, Git is kind of bad once it scales up really, really large. In my understanding, okay. I've never done this, but like that's what people have told me. And so all of Mozilla is actually, their monorepo is in Mercurial. And Facebook also had their monorepo in Mercurial until really recently. And what's kind of wild is, to bring it back onto the Rust topic, they had started writing a Mercurial server in Rust at Facebook called Mononoke. And now, at this point, they've forked Mercurial, and they've turned it back into a centralized version management system. And so, yeah, so it kind of like weirdly lives on as like literally all of Facebook's source code is stored in a Mercurial derived version control system. Okay. I forget what it's called these days, but it's like really interesting. It basically says on it, like, this is an open source repo, but we don't expect you'll be able to build it probably. You can ask us for help and we'll try to help you, but like right now it's just really rough. So I haven't really investigated it super closely, but yeah, it's kind of designed for big, giant monorepos. So yeah, it's still kicking around.
I mean, you hear me laughing in the background. It's interesting, the loops and bounds.
Yeah, totally.
Given Rust's heritage, let's put it this way, or legacy, it developed, or it was spun off rather, as a kind of low-level systems language. But whenever basically I give presentations on Rust, I compare it to Python, but only in a way more compressed, dense time span. Because if I take a look at the ecosystem that is out there on something called crates.io, I wouldn't say it's comparable to PyPy, but it's rapidly getting there. And it took Rust about 10 years, and it took Python 30 years.
Yeah, totally. And we had the benefit of a lot of hindsight with these things too. And so, we we made that tooling happen really early so that way everyone used the same tool. So that way we don't have, the battle of pip versus virtual end versus conda versus poetry versus pip end. I think I got all of them there. There's like 2 or 3 more. There's probably ones that somebody's really mad now because I forgot what their favorite one is.
Don't forget containers and virtual machines.
Yeah, right, exactly. So, we wanted to make sure that we had good tooling there, but also know that like network effects matter. Like, you can, because these all rely on the same packaging formats, it's actually really hard to optimize Python packaging because of legacy issues related to Python packaging stuff. But that's a whole nother giant can of worms. But yeah, so like the ecosystem is growing and we sort of wanted it to be that way and kind of made that happen sort of deliberately. So it's been nice to see it actually happening. Yeah, I think there's 50,000 packages on Crates.io? Let's see. Yeah, 59,000 packages currently. So, it's definitely not nothing.
For the few non-Rust programmers listening to this podcast, Crates.io would be the central package repository for us.
Yeah,
just
like
to squeeze this in. Yes, it's like PyPI, exactly. You see, what I found most interesting is actually Rust is under constant change. I think you put in changes every couple of months, if I'm not completely mistaken.
Yeah,
but at the same time, you're driving a very strict standardization. And Crates.io would be the primary example here, never mind Cargo, the build and package maintenance system.
Yeah.
And this is what I found very interesting.
We do release changes, but the key is they're all backwards compatible. So we add things, but we don't remove things. So we release every 6 weeks, which is very aggressive for a programming language. I think that 1 year is kind of the standard, and some take even longer than a year, but we do one every 6 weeks. And part of the reason for that is we actually find, ironically, that it lets you go slower because so if you have a once a year release schedule, and somebody proposes an awesome feature, let's say you release on Christmas. Ruby releases on Christmas, for example. So let's say someone suggests an awesome feature at the end of October or early November. So now you have these 2 choices. You can either rush the feature through to get it out for Christmas, or it's going to take over a year before that feature can even land. And so you end up creating this weird situation where actually having slower release cadence means that you end up rushing a lot more because you have this deadline and you kind of have to get to it. And so we found that by releasing every 6 weeks, it means that we can actually take things and keep them slower, because if you miss a release, it's only going to be 6 more weeks until the next one. And so that lets us be really slow and methodical about adding big new features, because we can just wait until it's ready and not have to feel rushed to make it out, before there's another year is going to go by. And we've deliberately waited on some features. Actually, the most significant recent feature that landed is this thing called const generics. And it landed in Rust 1.51, but it was actually technically ready at Rust 1.50. But we said, this is a big feature. And we really want to get it right. So we're just going to hold off one whole release, even though we think we could release it now, just because we want to be extra sure. And so that, wouldn't be possible if we released once a year. But when you're only talking about 6 weeks, it's no big deal. So yeah,
wait a whole year. Yeah, fair enough. I mean, for the listeners among them, we often have people from open source projects on, and would like to sort of touch a little bit on the way the project is organized in terms of structure, because you mentioned the releases and how does the project get managed, or how do features make it in there? How do you manage the project?
Totally.
There's many different models, right?
It's actually easiest to explain it through history. So, because it kind of grows, and I think it makes sense that way. So originally, Graydon's project, he's the only person, so he makes all the decisions. Then Mozilla adopts it, and they wanted to make sure, that it was bigger than just the creator. So they added 2 other people to sort of form this initial kind of council. And so that eventually became named the core team. And I joined it in 2014. And so at that point in time, we were about 8-ish people. And so we sort of made all decisions. People would make a GitHub issue and they'd ask about a decision and we'd say yes or no. And that's how things would happen. But as it came time to start getting around to releasing 1.0 and things really started ramping up, it became increasingly difficult because there was a wide range of things that needed to be decided. And a lot of times, not the whole core team would actually care. So for example, I found myself really focusing on documentation and like sort of the social side of things. And so I did less language design work. Like I'm not a type theorist, and there's lots of type theory stuff happening in Rust. And so if there was a question about, should we add this new fancy type feature, like I wouldn't really have an opinion, but some of the people who really cared about type systems would. And if there was like a new documentation situation that needed a call, I would be all over that, but the language folks would not necessarily care as much. And so also there became more decisions than we had time to make. And so we started developing this backlog of like every week, or we'd run out of time at the meeting. And so we decided to switch to a kind of more federated governance model. So what ended up happening in, I think it was like early 2015, we switched to a system where the core team still existed, but we split everything up into sub-teams. And those sub-teams would have full autonomy over their part of the project. And the core team would be more for like high-level product decisions and also cross-team communication. So we spun off the language team, had full decision-making power over the language itself. And the library team had full power over the standard library. And so that's like a little more decentralized than many projects, even the ones that have a core team instead of a BDFL. Like usually the core team makes all decisions. But in Rust, the teams themselves have full power over kind of everything. That's still the basic way that it happens today, except for there's a couple more details that matter. First, all the teams operate under consensus, not voting. So that's really matters because the team itself needs to all agree with anything for it to go forward. And so given that, we have a bunch of small teams, that really works. Like there's about 200 people involved in Rust governance now, 250, something like that. And so if we needed all of them to agree on every decision, that wouldn't really work very well. But when it's, the language team has 8 members and the library team has 8 members and they're different sets of people, it's much easier to operate under consensus. And we like consensus for a number of different reasons, a little more than voting. So we stuck with the consensus model, but we've done this decentralized kind of team structure to deal with
it sounds like a very good compromise between the dictatorship and the everybody has a vote kind of.
Definitely. And the other thing we've added now is we have working groups who are sort of like affiliations of people, but they don't have formal decision-making power in the project, but it gives people like a space to find out. So like there's a game development working group, for example. So if you're interested in making Rust better for writing video games, they don't get to decide what goes in the language, but it's like a forum for the people who do that kind of work to sort of work together. So we have that as kind of like a structure. And then finally, the newest thing is we have the Rust Foundation now exists. And this happened in the last couple months. And the foundation, unlike in many other projects where the governance of the project is sort of under the foundation's role in Rust is to support the project, not to be in charge of it. So the teams still have full autonomy over the project, even though the foundation exists. And the foundation is basically at this point like a place to hold the IP and a place to manage donations to be able to pay for things like CI expenses and legal fees and like all that kind of stuff. So they hold legal ownership of the trademark on Rust and Cargo and the logos. And they sort of do things like pay our hosting bill. So when you download the compiler, you're downloading it from an S3 bucket somewhere, and that bill gets paid for by the foundation, and stuff like that.
I mean, there was obviously the announcement of the new chair for the foundation. Does that mean that there is a large interest? I mean, I think you mentioned on previous sessions that all of Amazon Lambdas are touching a piece of Rust code when they go. So it seems that they have a fair bit of vested interest in the whole language.
Yeah, Amazon has made a huge investment in the language. So has a number of other companies that are like both on the foundation and off of the foundation, actually. So a great example, one of my most favorite recent examples is we now have tier 1 support for AArch64 because ARM themselves were like, hey, we really want this to happen. And they put in the work to write up the design documents. They donated us hardware. They did a bunch of stuff. And, so that's been really super positive to see interest from them. And basically every large tech company that you can think of has some Rust somewhere at this point. Facebook, Amazon, Microsoft, Google, Netflix. I think I've heard some rumors, but I don't know a ton about them. Like Apple, like all sorts of things. And that's both good and bad in many ways. It's really nice that they're used for that way, but also you always have to be careful. Corporate influence on open source projects is a really big hot topic right now. And so, we're starting to grapple with that ourselves as more and more big companies become more and more formally involved. We have to make sure that, we do what's right for Rust and not what the people with money think we should do, which oftentimes those things are correlated, but the trouble comes in when they're not, right? So,
yes. Yeah, I mean, with all open source, there is obviously the people have to have a living as well, right?
Totally. And so far, it's been really fantastic, and everyone's been very supportive. So we just gotta keep that up. But yeah.
Okay, so should you think? I mean, those big organizations choosing to use Rust for fairly substantial pieces of their infrastructure. I mean, that kind of ties into the attributes of Rust, right? Which is, I think, what struck me most about one of your previous talks was, again, that you mentioned that the finding of bugs is kind of something that doesn't happen as much as in other languages of that level, like C++ and what have you. Once you get it to compile, you're on a good trajectory of actually having something that's relatively bug-free, right?
You can't guarantee it's bug-free, of course, but you've found a lot of bugs that you may not find until later stages. It's interesting because I've been thinking about this more lately. I've heard some people talking about this, and this thing I think I agree with is it's not even so much that Rust prevents bugs or that it makes your code have less bugs. It's that it moves the bugs forward in time. So there's a lot of things in Rust that it catches at compile time that I would still have those bugs in my Ruby program. I would just see them happen in production instead. And so it's not really it makes more robust software because it forces you to confront those bugs earlier and deal with them immediately rather than putting them off. And it turns out that's actually it tends to be cheaper, before you have before you have the thing that makes your service topple over and that causes you to refund a bunch of your customers. It'd be nice if you caught that bug ahead of time.
It's almost like doing some design as well first, really. Writing stuff, right?
But it's hard
that kind
to
of
get
principle.
It's often hard to get management to agree that you should fix the bugs before release, though, And
indeed,
it's nice that you've got to blame it on, the code won't compile unless I fix these bugs. So, that's the way it is. So it seems like so far, Rust programs have less bugs in them to some, for various meanings of bugs and less, obviously. It's not a panacea. It's not magic. I've written many logic bugs in Rust programs. It happens. I would never claim that Rust makes your code bug-free, but it does help you deal with bugs earlier. And that tends to be a better way to do it. And that means it also can feel a little frustrating because you have to deal with them earlier. So sometimes people really get caught up in my code hasn't compiled for a whole day and I feel like I've made no progress. And it's well, no, you have made some progress. There's just a lot of bugs and you're being forced to deal with them now. And you got to iron them out before things happen. So it's tricky.
I can recall learning Rust. And it was, I wouldn't say a frustrating experience, but the learning curve was pretty steep coming from languages like Python, maybe C, maybe C++.
Yeah,
and you're absolutely spot on. The compiler is pretty strict in terms of the old adage still applies. If you can convince a Rust compiler to generate code, you're almost done. Apart from these few logic errors that you're referring to, fair enough. But to master that learning curve is not for the faint-hearted. I think in terms of, for example, I do not necessarily recommend for a beginner learning to program to learn Rust right away. Because the learning curve just might be too steep.
It's interesting because I also agree with you, but for a different reason, which is there's no materials aimed at helping brand new programmers. A long time ago, I actually used to teach people programming as a job. And so I have a lot of experience teaching people who have never coded before how to do it. And one thing that's really counterintuitive to a lot of professional programmers is that beginners' minds don't work the same way as people who've been programming. And I don't mean that in some sort of physical way, but I mean I've heard a lot of programmers express I would make sure to teach a new programmer Ruby, Python, or JavaScript because types are too hard and I don't want to discourage them from learning. But I've actually found that a lot of beginners intuitively understand the concept of types and they are confused that they don't exist. Because when you think about how we talk about words, we talk about the types of things when we use words to describe stuff. And so they want something similar in their programs. And so it's like kind of really, it's like really interesting that like a newbie can sometimes find different things easier or harder. And so I have a suspicion that some people might like programming in Rust as their first language because they've never learned the bad habits that cause people to struggle with Rust when they're experienced programmers. Like we found that some Ruby people learn Rust faster than some C people, even though you might think as a low-level language, it would be easier for C people to learn. And the reason why is a Rubyist has never dealt with pointers before. So the only thing they know is the way that Rust presents references. And so they tend to pick it up a little easier than a C person who's like, I know how to use pointers, so I'm going to do the same things I used to do. And then the Rust compiler like slaps them on the knuckles and is like, hey, don't do that. And then they get frustrated and they leave. And so I suspect that there might be some folks who would be good to learn Rust as a beginner, but there's just no supporting resources for them. And so I think they'd be mostly set up to fail at the moment. But who knows? We'll see if anyone ever bothers to write that book and gives it a try. I don't know.
So for all your budding psychiatrists out there, there's a new business niche. Consult the tainted mice in terms of hardened and advanced programmers. Just to go back to the beginning.
I think about this problem all the time, though, because as the documentation person, it's sort of kind of at least partially my job to teach people Rust, and so I need to figure out there's this really common thing where people will try Rust. They'll find it too hard. They'll quit. 6 months will go by. They'll come back. They'll say, I'm going to give it a try again. And then they find it a lot easier. And they're like, I don't remember why it was so hard the first time. And I have never been able to figure out what it is to get people to skip that weird 6 month quit period. But it would be great if I could figure out what it is.
I mean,
I just have no idea.
I wouldn't commit on the 6 month, but you're talking to one of them. When I first picked up Rust, the learning curve, as I said, was pretty steep, but then it took about 2 to 3 months to get back into the swing of things. By no means, full disclosure, I'm not a Rust expert. I just give presentations on Rust and try to convert the parish, so to speak.
Right.
But I find this really interesting and really fascinating because once you get the hang of it, Rust code is actually easier to write than C++, Python, and some other programming languages that come to mind for exactly these reasons, because the compiler takes you by the hand and actually guides you there. The way to your goal might be a little bit tricky, but I think Rust is one of the few compilers that actually gives you HTML links as part of the error messages.
Yeah, it's definitely put a lot of work in there, and there's a couple of contributors over the years that have really focused on error messages and making them good, and it definitely shows. I'm really thankful for their work for sure. But yeah, it's definitely kind of funny. Yeah, the whole learning process. I don't know. It's a tricky problem. I'm still trying to figure it out. We'll see if I ever crack that nut. Maybe it turns out you just need to practice. But this is also why we try to be really upfront with people that hey, if you're feeling frustrated, maybe Rust isn't for you. It's totally fine. We'll still be here in the future if you change your mind. And I think that's been kind of necessary in order to help people out because we don't want to be we want to encourage people, not discourage them. So it's interesting for sure.
Yeah, no, I mean you've obviously seen a lot. I think you mentioned at the start you saw a lot of Ruby Python programmers converting to Rust or adopting it. Is that the predominant kind of uptake of the Rust language?
Well, there's kind of 3 groups of constituents is how I like to describe it. So there's the C++ people, there's the Ruby, Python, JavaScript people, and then there's the Haskell, OCaml, Scala people. And so you kind of have this I sort of call them systems people, scripting people, and functional people. And Rust is kind of all 3 of those things shoved together. And so it's really interesting because each group will find certain things really easy about Rust and other ones will find it really hard. And so they almost need different learning resources sometimes because it's amazing to watch a C programmer use cargo for the first time and they find it kind of difficult because it's not a makefile and they know makefiles really well. And so they're it's a totally different paradigm. And so they struggle with it a little bit sometimes. And you find a Ruby person and they will have to learn pointers and they'll struggle with that. But they'll get cargo instantly, and the C person will get references, relatively easily, and so the C people will reach for a for loop more often, and the functional people will reach for a map. But like it's kind of like different people bring different perspectives and they struggle with different things. So in terms of the size, one thing that's kind of interesting is that I do think the scripting people are the bigger audience now, but that's really just due to the sheer volume of people that exist, more than like a desire or like even necessarily maybe like a usefulness to that audience. Like there's just so many people that know how to program in a scripting language that, if you got 0.5% of the people who knew Ruby to try Rust, that might be bigger than if you got like 1% of C programmers, because there's just a lot more people that know higher level languages. And so I think that they are a bigger constituency, but just purely due to numbers, not because it's like better for scripting or whatever. And this is kind of been common in a lot of newer languages that have uptake, is they like realize like, oh yeah, we're getting a lot of people from scripting languages just because the number, I mean, even just JavaScript alone like is massively larger than almost every other programming language. And some of them you can put together. So it's you're much more likely to run into a JavaScript dev than you are a hardcore low-level C++ programmer.
Mm-hmm. I mean, sorry, Chris. I just want to follow up on the learning piece. Like most of us who've done computer science, we are, well, apart from those of us who started programming in BASIC when we were 7, we obviously learn how to program or touch upon different programming language during our course, right? Is this something that you're trying to encourage in university spheres, or?
Yeah, I mean, to some degree, like I would say that we have tended to try to be supportive when it's already happening, but we haven't like done proactive research. Like there's no like, I'm not showing up at university campuses with a Rust book in my hand, knocking on a professor's door being like, hello, do you have a minute to talk about your Lord and Savior, Ferris the Crab? Yeah. But we have had a couple people do university classes, and we've tried to be supportive. Like I have gone physically before COVID, obviously. I have traveled to some universities where they were running a Rust class to drop in and say hi and like whatever. And there's been some like university hackathons every year. They have some Rust people and like some stuff like that. But the university stuff changes pretty slowly and it takes a lot of time. So we have seen, it's probably like 10 classes pop up, which is not zero, but not all of them. And so, totally. Non-zero, but not many of them.
Okay.
Very interesting, Steve. Yeah. Changing the tack a little bit. Rust was originally designed as a low-level system programming language, but with the recent additions to the ecosystem, I fully get it where Rust is going. But at the same time, you see still this, I'm always tempted to say, rejuvenation of the language in terms of going back to its origins. You have the Bottle Rocket project from AWS, which is essentially a container-based operating system, container-based Linux platform for container deployment written mostly in Rust. Yep. Microsoft apparently is pouring big dollars into the technology for their future programming projects. And there is this little operating system called Linux, I think it's called.
I think I've heard of it. Yeah. Yes. Nothing big and professional like you.
Exactly. Right? No, not at all. And there was this conference in 2020 called the Linux Plumbers Conference, where a guy called Linus Torvalds actually said he could imagine seeing Rust entering the kernel. And he commented on this.
Yep. So I think it's good. I actually was at a Linux Foundation event one time, and I was in the same room as Linus, and I really wanted to go ask him about Rust in the kernel. This was in like 2014, 2015. It was way too early, and I was like, I don't want to be that guy. But I was like, I really, really, really want to be that guy, and I didn't do it because I thought it would be bad. But I do think it's really interesting and exciting. We always kind of like. So one of the reasons why it's named Rust is it's supposed to evoke the feelings of like a well-worn tool. Like things only get rusty after they've existed for a while. And so Rust is kind of like, it's funny because it feels like a cutting edge programming language, but that's also because industry languages were all made in like 1995, basically. I don't know what they were like putting in the drinking water in 95, but that was an amazing year for programming languages. Like you have Java and JavaScript and Python, Ruby were similar. Python's a little older. Ruby was 95 as well. Python was slightly before that, but like the sort of mid 90s was like where most of our very popular languages sort of come from. And so Rust is kind of like a cutting edge programming language from like 2008. And so it's really funny because if you talk to like programming language theory people, they're like, oh yeah, like Rust doesn't have anything new in it. But if you talk to industry people, it's like, this has all this stuff I've never seen before. And so the part of the reason why that was chosen is because we wanted to only include stuff that had seen some use and we knew would be useful for real world things. Like Rust has always had the intention of being a programming language that was used to build things and impact the world and not just be a research playground. And so it's really exciting to see it finally kind of like continue to grow into more and more useful, big systems. Like it used to be that I would give talks about Rust and I'm like, yeah, I've heard some rumors that some companies are going to use it someday. And then it would be like, oh, like, Dropbox was the first like big company that I would like talk about as using Rust. Because that was in 2014, they started using it. And so I was like, Dropbox use it for real things. And then eventually it became like, okay, here's 5 of the 10 companies I know about. And now I like run into people who are using Rust for real production things. I've never met or heard of them before or what they're doing. And that's like really, really awesome. I'm really happy about it. And so I'm excited to see both the tons of little people using Rust and also the biggest companies. Because, that's how you like people make decisions about their technologies based on who else is using them. And to be able to say that these big companies are using Rust is a really strong showing of social proof that allows a lot of smaller companies to be able to use Rust. And so I think it's important and useful.
So given the niche character of this tiny programming language, where do you see this going?
Yeah, well, I mean, I think it really like depends. I think that, the signs all look good, but there is a chance that, for example, so that the Rust code technically has landed not in the Linux tree proper, but in like the beta branch, so like Linux Next. And so it's not quite in there yet, but like maybe they do a little more work and it turns out actually it's horrible and they pull it out and they say no, right? Like we're at this interesting like kind of cusp moment with many things. Obviously it's been in production at Amazon and Google and Facebook and blah, blah, blah. So that's definitely there. But like, I still, because I've been around since the old days, it still doesn't quite feel real yet. So I'm always like, when does this go wrong? Like, where's the point in time where they wake up and like, oh, never mind. Actually, turns out, tomorrow. So the thing about Lambda is like Firecracker is this VM technology that Amazon's been working on, and every single Lambda execution goes through Firecracker because it's kind of the underlying virtualization technology that makes Firecracker work. So, what happens when I wake up tomorrow and turns out every single AWS Lambda has stopped working because there was like a bug in the Rust compiler, and now it's a big problem, and like what did happen? Maybe I have an anxiety problem. Who knows? But I think that
I'm sure they got a good testing program.
Yeah, hopefully they got some good testing and make that not happen.
Yeah.
But like. Yeah, so so part of me is just really like waiting until these success stories are successful for a while, and then we'll kind of see where things go. But I think that the biggest question right now, like Rust is definitely being used in low level stuff very successfully. The question is, how high up the stack is it a reasonable choice for? And that's a question that has been evolving over the years, and I don't think we have a full good answer on yet, because like, if you had asked me in 2013 if I thought you should write a web application in Rust, I would tell you definitely not. And now I would say maybe. Like my company is basically writing web applications in Rust and it works great. And some other places are doing so and it's fine. But it's not clear it's always a good fit in the same way that many other things are. And so, I don't know what place in the stack it is unquestionably an amazing choice, like how far up the stack that goes. Because I think the answer is definitely yes for the lowest levels of the stack, but it's unclear where it caps out, basically. So we'll see.
It's an interesting perspective because you just mentioned web frameworks. I can recall, I wouldn't say a feud, but a discussion, let's put it this way, a few years back with regards to something called Arctic's Web. Maybe before we go into the details, because I think that teaches a very important lesson about community management and all the rest of it, maybe we should explain what Arctic's Web was all about and why the controversy actually sparked.
Totally. So Actix was a project to build an actor system in Rust, so hence Actix is like the name for an actor system. And Actix Web was a web framework built on top of Rust actors. And so that was going pretty well. I think eventually Actix Web actually dropped Actix support and kind of ended up becoming its own thing. It didn't use actors anymore, but I'm not 100% sure about that. But anyway, the point is that it became very fast and started to appear. There's this benchmarking suite that's really popular called the Tech Empower benchmarks, and it benchmarks web framework tests. And so Actix showed up and started like just absolutely demolishing the charts. Like it was really, really faster than all this other stuff that had come before. And so it got a lot of attention very quickly. And so that's kind of like the backstory is web framework, written Rust, extremely fast and very powerful. I don't know if you want any more background or if there is anything I didn't cover before we talk about the controversy.
I think the important lesson is actually what happened to the community.
Yeah.
And why.
So the problem happened is this attention meant that more and more people started looking at the internals, like how is this so much faster? And part of that answer was unsafe code. So Rust has this concept of unsafe, and basically like Rust has all these rules that it uses to check to see that your code is good or not. And unfortunately, CPUs aren't built to encode Rust's rules in them. So there's kind of this point where when you're doing the lowest level stuff, like you make a system call. System calls are inherently not built into the Rust language, so it can't know how they work. So we have this concept called unsafe that basically lets you do whatever you want. There's a lot of caveats there, but we could fill a whole hour just talking about just that alone. But the point is that there's kind of like an escape hatch that lets you do things that are, maybe a little more dubious by Rust's normal standards. And so what this means is...
Like here be dragons from now on, that sort of thing.
Yeah, like you get access to the same pointers you have in C with no checks. You can do anything you want. You want to cause a seg fault? Totally possible. And so it's on you as the programmer to make sure that you've done the checks appropriately. And so naturally people looked into this and they found that some of the reason why Actix was so fast was because it made some pretty dubious usage of unsafe internally. And what made the situation so complicated was that it's stuff that wasn't necessarily, strictly speaking, clearly wrong. So it's easy to resolve a situation if it's like definitely wrong and you point out how it's wrong and then people say thank you and they merge the pull request and the bug is closed. But when you start getting into debates about is this even wrong in the first place, that provides a fruitful place for arguing. And since this had gotten so much attention, it was so popular, a lot of people saw it as kind of like a flagship project. And so a lot of people got kind of upset because they felt like a flagship project was doing shady stuff internally, and that would look bad on Rust. And so there started to be like a back and forth that was not very productive about the ways that Actix used unsafe. Part of that was also people submitted patches to remove the unsafe, and the maintainer said no, and closed them. So then people got mad that he closed them because they thought he should accept the things and like blah, blah, blah. And so eventually he burned out and he quit. And he originally deleted the project, but then he undeleted it and gave it over to some other people instead. And so we had to kind of have this like, sort of like community discussion about like, is this behavior acceptable? And, and by this behavior, I mean the community hounding a maintainer until he quit his project. And like, was this handled the right way? And how do we want to go about this in the future? Obviously, we can't control the way that literally everyone who says they like Rust acts, but we sort of had to decide, like, was this a good outcome or not? And if so, what do we want to do differently in the future? And so, I thought it was kind of a pretty embarrassing for the Rust community in general. So I think everyone now like has kind of chilled out and sort of recognized that was like not a great look for anyone. And the project has new maintainers and they're doing their thing, and it's still a pretty performant web framework and all that stuff. But it matters. The people part of this is definitely important, and it's complicated. So that's kind of the summary of what happened.
But Steve, isn't that the best example for something called evolution?
Yeah, maybe
because this is driving the overall FOSS I wouldn't say heritage, legacy, but spirit. That's what I'm looking for. If something doesn't work, people will change it. And if they fork it, they fork it.
The thing is that evolution requires a lot of death, and it's not really comforting.
It does, yes.
It's not really. It's not comforting if you're the person that needs to die so that evolution can work, right? Like that's not. I'm not like, oh well, sorry, you got to die now because that's just evolution. And you're like, yeah, but I'm still going to die, so I'm not happy about this. And I'm like, well, I mean, and the other thing too is people always forget evolution is a process where the next generation does things better, right? And so there's, forking is important. But yeah, like the thing is there like wasn't forking behavior. And I think this is also part of it too, is that it's not like people forked it and said, we're going to make it but better, and then left the original guy alone. Like one of the interesting changes, I think, as we're getting close to the end of the hour, actually talk about open source stuff. One of the things that I think has changed culturally about open source is there's less of forking is seen more aggressively today than it used to be. And there's more pressure to incorporate changes into some sort of canonical upstream. And what that canonical upstream does is more important to people than it used to be in the past. And so I think that's also part of this story is that, if this had happened the same way in the 90s, some group of people that weren't happy would have forked the project, made their own version of Actix, but safer or whatever, and they would have left the original guys alone. Maybe there would have been some mailing list arguments and they would have yelled at each other or whatever. But I think there would have sort of been this co-evolution instead of an intense pressure on the upstream to change their ways. And that's tricky.
Full disclosure, because our legal department insists on this normally. Kids, full disclosure, people didn't die.
Yes.
when Actix happened, sorry. So only code, exactly. Only code bases as part of the evolution in the open source ecosystem basically die or are left to bit rot. Totally. People do not die, just code bases on places like GitHub or some other hosting platform. So only digits fade away, not people, before their natural end, of course.
Yeah.
Martin, any final questions before we wrap this up?
Yeah, that's been great so far. So far, actually, we are at the end, aren't we? So it'd be good to keep talking, but I mean, I think. What do you see for yourself? You mentioned your Ruby kind of history and how you moved on from that because you're kind of done there. Do you see something happening there yourself in the Rust scene as well? Or?
Totally. I mean, I'm sure at some point, I will reach my natural end, as just described earlier.
Token of the maturity of Rust as well, right?
Unless Silicon Valley invents some sort of immortality tech and I magically get to live forever for some reason. I don't think it's going to happen, but whatever. There will be at some point. But yeah, I mean, it definitely as projects grow and change. So I am the oldest current existing core team member. Everyone else who was on the core team before me has left at this point.
Wow.
And so, there's sort of a certain amount of interesting thing there. And I also think it's important that people move on because you need fresh new ideas too, right? So if something is connected to any one individual, it's not robust, specifically because of these kind of pressures over time. And so we've added a lot of new people to the core team. And so, at some point there is a time where I should probably step back a little to make space for new people that want to do work and get involved in things. I don't know when that's going to be, but I'm sure it will happen at some point. And to some degree, I guess that's already happened in some ways because it used to be my full-time job to work on Rust, and now I do it, nights and weekends. So I do put less time into it than I used to when it was my full-time day job all the time. So to some degree, back a little bit, but I still really love using Rust, and I love writing Rust and being around Rust people and doing all those things. So I have no immediate plans to kind of actively move on, but I am excited that other people are also doing cool things and seeing how that works and trying to make sure that if people want to do stuff that I'm not taking up space that someone else really wants to do. So it's always an interesting balance.
It's an interesting observation about the new people, because if I look at a project that I'm quite familiar with, which is Postgres. The core team has been there for many years, right, in the same form. So it's quite the contrast to what what you just observed about Rust.
Please note, Steve referred to Rust people, not rusty people. This is the difference here.
It's true. Usually we use the term rustations, which is kind of fun.
I'm just saying.
Yeah, totally. But it's good.
Okay. We have a very special segment of each and every show where we have a guest on, but we do without guests too. The closing segment is actually we talk about proxies, and proxies are of course the picks of the week in terms of something that comes across as being worth mentioned in terms of favorite book, favorite movie, that sort of thing that you think is worth talking about in to the about 4 people that we have listening on a regular basis. So, Martin, why don't you start us off with the pox of this episode?
Yeah, I'm not sure whether it's a pox or anti-pox, but I found the announcement of OpenSearch quite interesting as from the whole open source scenario and the licensing, and there's a lot of support for it, which is for various reasons, but that's the one that struck me for this week.
Maybe we should explain what OpenSearch is, just for the uninitiated.
Yeah, it's basically AWS's fork of Elasticsearch because of the licensing restrictions that they put on it, and it's had a lot of support from the open source communities.
I actually saw a funny take on this. I think your description is accurate, but I found another description which I also think is accurate, which is Elastic forked Elasticsearch themselves, and Amazon has now taken over the original project. Which is like a very like it's kind of true and kind of a little weird. But yeah, totally.
Yeah, I mean they have a point. Yeah, I mean Elasticsearch really goes so far. Exactly. My pox of the week would be, of course, totally non-technical, and Martin would probably be the benefactor here because the pubs actually opened on Monday in Great Britain for outside business, if I'm not completely mistaken. Due to the COVID situation, yes. So no further explanation needed, as long as you're living in the UK. For those few people not living in the UK and listening to this podcast, pubs are places of business where you can get intoxicating liquor. Just in case
that's the side factor. It's mainly to get together with people.
Who came up with that idea?
And the socializing factor, of course, would come in play. But without further ado, Steve, what is your pox?
Okay, so mine's also going to be non-technical because the thing I've been most interested in lately is bullet journaling. So I've been one of the interesting things about running a lot of open source projects is that you need to be organized. And I am terrible at being organized. And so I've been doing different things over the last couple of months to try to get into it. But a couple of my friends have started looking at this, and it's not a new thing by any means. But so bullets, like a bulleted list, and basically it's just a strategy for you to manage stuff like to-dos, but also any notes that you kind of take. And it's a fully analog system. So I have here on my desk an actual.
Pen and paper?
If you put pieces of paper together and you put some glue, it's called a binding. It's like an iPad. It's like if you stack 20 iPads on top of each other. So I have a little notebook and a pen, and I've been writing down. So I have here, on my for today's journal, I have, go on the, Linux Inlaws podcast at 1, and in 5 minutes or whenever we're done here, I'm going to check that off. But I've been experimenting with, instead of having complicated software to track my to-do list, doing it analog style, and it's only been 3 days, so I can't tell you if it works well or not, but I'm interested, and my handwriting is terrible, so we'll see if I can even read my notes the day after I write them, but it's been kind of cool, and you can sort of learn about the system as bulletjournal.com or whatever, but yeah, it's been fun.
I mean, this is most amazing. One of the key contributors to one of the forefront hipster languages using analog technology.
Yeah, totally.
This is most amazing.
So we'll see how it goes. But I think it's interesting. Almost all my life is computers all the time. So doing some stuff. One of the reasons I like doing embedded work is you get a little physical computer you get to see, as opposed to the big desktops or laptops or whatever. And so it's kind of another, just like, oh yeah, maybe I should interact with the physical world every once in a while. So I think writing a paper is kind of fun.
Cool. So Steve,
who knows if I'll continue doing it or not?
Yeah. So Steve, let us get you back on the show in about 2 weeks to report on the progress here.
Yeah, totally. We'll see how it goes.
Steve, that has been more than insightful. Thank you very much for participating.
Yeah, thanks for having me.
And really looking forward to having you back on the show in a few years' time to see where this Rust thing actually went.
Yeah, we'll see what happens.
And with that, thank you for listening. This is the Linux Inlaws.
You come for the knowledge,
but stay for the madness. Thank you for listening. This podcast is licensed under the latest version of the Creative Commons license, Tab Attribution Share Alike. Credits for the intro music go to Blue Sea Roosters for the song Salute Margot, to Twin Flames for their piece called The Flow, used for the segment intros, and finally to Celestial Ground for their song Sweet Justice, used by the Dark Side. You find these and other ditties licensed under Creative Commons at Jamendo, a website dedicated to liberate the music industry from choking copyright legislation and other crap concepts.
You've been listening to Hacker Public Radio at hackerpublicradio.org. We are a community podcast network that releases shows every weekday, Monday through Friday. Today's show, like all our shows, was contributed by an HPR listener like yourself. If you ever thought of recording a podcast, then click on our contribute link to find out how easy it really is. Hacker Public Radio was founded by the Digital Dog Pound and the Infonomicon Computer Club and is part of the binary revolution at binrev.com. If you have comments on today's show, please email the host directly, leave a comment on the website, or record a follow-up episode yourself. Unless otherwise stated, today's show is released under a Creative Commons Attribution Share Alike 3.0 license.